Hi, everyone. Thank you so much for joining us today. Looking forward to having a great conversation about the world of modern data architectures as we go through a compare and contrast of a lot of the modern data architectures out there and introduce sort of a new phenomenon in the world of data architecture, Dataware, which we'll discuss further as we get on. Before we get too far into it, let's start with some introductions. For those of you who don't know me, my name is Joe Hilleary. I'm a senior analyst with Eckerson Group, and I'm joined today by Dan, who's the co-founder and CEO of Cinchy. Dan, why don't you introduce yourself? Tell us a little bit about where you're coming from.
Sure. Thanks, Joe, for having me. So yeah, I'm Dan, the CEO, co-founder of Cinchy. My background prior to founding the company is I used to work in a bunch of big, complex enterprise organizations, mostly in financial services. So think big global banks that had a ton of complexity, lots of challenges with integration, data everywhere yet nowhere. And that was kind of the inspiration for creating the company and the technology. And that's why we're so excited about this concept of Dataware. I'm happy to be here.
Thanks so much for joining us. I'm looking forward to your insights. I always enjoy our conversations. A little bit about Eckerson Group, for those of you who may not be familiar with us. Eckerson Group is a small research firm. We focus exclusively on data and analytics. We also do some consulting. You can see some of our recent clients here. As always, you can check out any of our written content online at www.eckersongroup.com to see any of our white papers, articles, including on this topic. So today we're going to be talking about the evolution of architectures for analytics. That's going to be our lens coming in. And so to set the stage, as most of you probably know, for decades now, there's been a general practice within data analytics where we've got a bunch of data coming from a number of different source systems. To do analytics, we got to bring it all together. So in the paradigm that exists today, all of our applications have application databases that store the operational data that runs those applications, allows users to interact with them. And for analytics, we use integration, we use data pipelines, and we copy and move data from those databases to some sort of central repository for analytics. And from there, we can perform actions like business intelligence and data science workflows on top of that collected repository. So most of the modern data architectures that we're going to talk about today fall into this general structure. How that repository is organized, the kinds of data that we can move, some of those things will change, but this is the general abstract framework for analytics. The key is centralization. We've got a lot of fragmented data. We got to bring it together before we can do anything with it. Dan, do you have any comments here you'd like to add before we talk about sort of Dataware, which I know is your area of expertise?
Yeah, no, I think if you really think of the evolution of technology, even for a second going beyond analytics, the reason this is the way it is the concept of creating applications predates the understanding that you can get a lot of value out of your data, because its initial purpose was to basically act as the memory of your applications. So you ended up with a world where we architected systems that each stored and managed their own data, with that later realization that we can get value out of that. Well, right now, we already have silos. We already have fragmentation. The only option really is to take copies out of that data and put it in a central location in order to mine that intelligence. So it is really kind of the natural part of the evolution of technology. So, and the other thing as a result of that, the boundary between how do we think of application architecture versus data architecture has been really defined to the in between on your visual here between the application databases, and everything to the right of that is kind of like your data architecture, and everything to the left of that is your application architecture. And one of the things I think Dataware does that's fundamental is it redraws those boundaries such that we start to look at how apps manage data when we think of data architecture. So taking a more holistic approach, I think that's where everything changes.
Yeah, that's a great segue, Dan. And we've mentioned Dataware a couple of times here. So I think for most of you, it's probably a new term, and it's worth talking a little bit about what we mean when we talk about Dataware. So Dataware is an idea that's been around for a long time, sort of theorized in some of the early computer science movements. But if we think about software and hardware is the circuitry. It's all the pieces that send electrical impulses through logic gates, moves our data around on a very physical level. Software is sort of the set of instructions. And as Dan mentioned on the last slide, software in a historical paradigm typically has come packaged with databases that allow it to access data during operation. Dataware is sort of a proposed third layer, separate from hardware or software, that manages all of the data So in the same way I could have multiple pieces of software running on a single piece of hardware, my laptop runs, how many different applications every day. I could run multiple pieces of software on top of a shared data layer, a shared dataware, if you will. And so one of the big adjustments is that framework in how we think about the distinction between analytical data and operational data, and the software development and data development frames of reference. So I find this is a sort of helpful way to look at it. If we compare this slide with our previous slide, we're sort of removing this application database layer. So with Dataware, we're building apps directly on top of a shared data backend. So instead of having to integrate between applications and between applications and analytics, which is going to be our focus in this conversation today, the applications are already using a shared pool. We're not having to put Humpty Dumpty back together again because we never let it fall off the wall in the first place. But in terms of the analytical context, we still have that shared repository of all of our data in one place that allows us to do business intelligence and data science work on top of data from all of our different sources. It's just that our different sources don't have separate application silos to start with. Dan?
Yeah, I like the analogy that you gave in terms of the fact that you can run more than one application on a single piece of hardware. I've never heard you say that before, but it really resonated, because I'm just thinking I have an iPhone that has probably a couple hundred apps on that. Imagine if that was all separate physical devices, if every app was its own device. Like today, we would think that's just completely preposterous, but it's kind of the same scale that we're talking about here. It's just, when this is new to you, it's hard to kind of envision, but once you see it, once you experience it, the idea of reverting back to apps managing data independently would almost be as preposterous and ridiculous as it would be that every app was a separate device versus one device for many. So I really like that.
Yeah, absolutely. We've got a question coming in here asking about the challenge of having multiple applications work against a shared data backend, and the concern that it would take a long time for applications to embrace that approach. And so thank you for that question. We're going to address that a little bit today, but we're actually, this webinar corresponds with a white paper that's going to be coming out as well that you'll be receiving a link to after the webinar is over, that goes into that a little bit more in depth, but we can address it here a little bit. And so one of the key pieces, and we'll also actually be doing a second webinar that focuses a little bit more on Dataware, where we'll have time to dig into this more. But one of the key pieces of Dataware, the way it works, is collaboration software. So sort of if you think about Google Docs, you think about some of those collaboration productivity apps where multiple people can kind of edit the same document file at the same time. There's sort of a similar technology being used in Dataware platforms to enable those applications to interact with each other. And Dan, I'll let you field this question because I think you can probably speak to it a little bit more.
Yeah, no,
you
captured the essence of it. That problem. Yeah, because I remember going back, even when I was working at big banks, there was always this an anti-pattern of a shared database, and it was an anti-pattern because who owns the schema? How do you not step on each other's toes, even across like 3 applications, let alone 10,000? And that's just because databases, while they could potentially technically be shared across applications, they didn't have the capabilities because they were never designed for that purpose. They're not designed to be used by teams and people. They're designed to be used by code of an application. So they don't have those collaboration capabilities. They're not designed for basically enabling the decentralization of ownership of the data model, as an example. It's not designed for the metadata management such that it has controlled workflows. Like it's basically doesn't have the capabilities because it was never intended to be that. That's not the purpose of what the database was. That's really what's changed with the introduction of Dataware, is the enablement of those capabilities. And the analogy of Google Drive is one I use myself a lot. And I think that kind of sums it up. Like file storage to file sharing to file collaboration, data storage to data sharing to data collaboration, same thing.
And again, I would encourage you to join us for our next webinar as well, where we'll have sort of an opportunity to dig a little bit more into how a Dataware platform works. Here, we're going to be talking about modern data architectures. And so we're going to go ahead and launch into that piece. Probably the grandfather of all of our modern data architectures is the data warehouse. So that was sort of revolutionary, comes out of the 80s, 90s, really catches steam in the late 20th century, as all of a sudden we realize the potential for analytics if only we could bring all of our data together. And so the data warehouse was revolutionary in that regard. It allowed, for the first time, the ability to centralize access to all of your data from all of your sources. And so it did this by imposing a schema that made it very queryable, and by copying and moving that data from all of those application databases into one location. This was huge. but it had some limitations, particularly around that need to copy and move data, could only really deal with structured data because of the need to sort of implement a schema. But it was doing things for the first time, like centralizing governance and facilitating business intelligence that produced tremendous value for those early adopters and has become the standard practice across most industries. You'd be hard put to find a company these days that doesn't at least have some form of data warehouse, at the very least, in terms of thinking about their analytical architecture. You could do a whole webinar on data warehouses, and hundreds of them I'm sure have been done. But for our purposes, it's useful to think about this as sort of the starting point as we think about the data architecture within the analytical space. Dan, do you have any thoughts?
Yeah, and one thing to maybe just put it into perspective, if you're contrasting that to say Dataware, is why don't you run the entire organization on your data warehouse? Well, the answer to that is generally your data warehouse isn't calibrated, it's not designed to replace application databases and support transactional workloads. It's one of the major challenges. Often you start with great success, but as it scales, who owns the data model of the warehouse? Who's this master modeler or this master modeling team that knows everything about every nook and cranny of the business? The answer is nobody. So that becomes the challenge. And we'll talk more about that in a couple of slides around the need for federation.
Yeah, absolutely. So one of the first challenges I brought up there was this copying and moving data. So sort of in the next wave, we see an attempt to address that with data virtualization, right? So we have found some of the issues with the data warehouse. We start to virtualize data, right? We federate queries that allows us to work with our data where it resides. We can query data in those source systems. We don't have to move it to the central repository. We sort of create a logical data warehouse, right? And that's the term that sort of catches on at this point, where we've got all the functionality and structure of a data warehouse, but we don't have to move the data. And so there have been some challenges with this, both in terms of sort of query efficiency with those larger federated queries, but also you still sort of have those same fundamental limitations of the traditional data warehouse with the logical data warehouse, where you've got centralized access, but your data is still sort of pigeonholed within the framework of the warehouse. So you've got to have that structured schema. You've got to work primarily with structured data. You're not really able to pull in unstructured data sources. And as Dan referenced, again, you're not running applications off of a logical data warehouse any more than you're running applications off of a regular one. But it is facilitating those analytics without the need to move data. So that's kind of the big step forward within that space. But virtualization as a tool becomes an important piece of later modern data architectures, including Dataware, right, Dan?
Absolutely.
We look at.
Yeah, for sure. Yeah, one thing that we have to remember is, again, everything that we're doing here and even the scope of this webinar is centered around analytics. But when you zoom out of the analytical plane and start to look bigger picture, that's when all of a sudden all these observations start to reveal themselves. But traditionally, we're either heads down in the operational or transactional plane or heads down in the analytical plane. And is that zooming out that is, I think, one of the major catalysts for driving this change. Because even in the context of virtualization, by avoiding the copying and moving of data to support analytics, well, the apps are still exchanging data. They're calling APIs and ETLs and doing all of that. So that doesn't go away. And nor was it intended to go away as a result of this.
And we've got another question. How does data virtualization address application integration? Dan, I think it's a little bit of what you were just talking about.
Yeah, and I would say outside of maybe some anomalous use case, it really doesn't. Generally, you're going to be using some type of middleware, which could be doing some type of integration at the code level via APIs, more recently using like REST and JSON, or more at the data layer using things like ETLs to basically exchange information across applications. So generally, whether you're doing point-to-point or point-to-point via a common middleware, you're still connecting them in largely the same way that you did quite a while ago. So virtualization didn't really disrupt that. But again, it's not that it's failed to do that. That's not what it was really designed to do. That's not what it was intended to do. What was really driving it was the hunger for analytics and the belief that the effort to and cost of physically moving and copying data was the major impediment. Hence, we'll make it virtual.
Right. And we see that sort of ramification in some of the later applications or architectures that we'll look at in this webinar. In terms of that virtualization piece, right? As soon as this technology exists, it can be applied to things beyond sort of the logical data warehouse. That idea of federating queries pops back up again. So next thing we're going to look at is the data lake, which set out to solve a very different problem with the data warehouse. So you can kind of think it's a little bit of a fork almost, solving something that data virtualization didn't solve, but not solving what data virtualization did solve. It's sort of more of a step sideways in that respect than sort of an evolution from data virtualization. So a data lake, our big advantage here is the ability to deal with unstructured data, right? We see the data lake come out of a moment when data science is really catching on, and data scientists are going, hey, I don't need this hyper refined data that's coming into the data warehouse. I can't do anything with that. What I need is high volume access to large amounts of raw data to train models, to build machine learning algorithms. And a lot of the data that I want to work with is unstructured. It's not going to fit inside your nice, neat schema within the data warehouse. Just put it all in one place and I will go find it. And that's kind of where the data lake comes from. I mean, the initial implementations revolved a lot around Hadoop and sort of all these new approaches to dealing with the volume of data that we saw kind of come into being in the early to mid 2000s as big data started to take off. And then, of course, we have cloud data lakes now, and that's been a shift for data warehouses as well, that shift from on-prem to the cloud. But the idea is essentially, okay, just shove all the data in one place. Don't even worry about it. We're just going to work about centralizing. We're not going to worry nearly as much about schema or structure organization. So that has the huge benefit of now we can deal with much larger volumes of data, and we can deal with unstructured data. But again, we're having to copy and move all of that data into this data lake environment. And our governance, there's the idea of data lakes turning into data swamps has become really hard to govern and query across this. We don't really have an understanding of what's there. It's just a huge mass of data.
Yeah, and so that includes the structured data from each individual application, which is in isolation structured. But when you piece it together by taking it in its raw, even structured form, that's where you have scenarios like where J. Smith and John Smith and Mr. Smith is one person, or is that three? And which field is the first name? And, all those challenges. So even in the use of structured data, it's still a problem because it's not forcing the schema normalization, be it centralized or decentralized. It's essentially deferring that.
Right. And so that kind of brings us to the next innovation here, which was the data lakehouse that said, all right, we've got these problems around dealing with structured data in the data lake that we were doing fine with the data warehouse before, but we weren't doing it effectively in the data lake. But we need the data lake to deal with unstructured data. We need to deal with the volume of data. So you have this idea of the data lakehouse, which is basically, okay, what if we had a data lake and then we stuck a warehouse on top of it? So we still took the data warehousing approach to the structured data, but we allowed it to sort of live within the same environment as the data lake that has all of our large volumes of unstructured data, or data at different levels of refinement, right? So we have, sort of an island somewhere in the middle of our lake, and it's got a little data warehouse on it. And that makes it really easy for our business analysts to query that, to do all of the analytics workflows they were doing before we went to the lakehouse approach. But our data scientists are still happy because they've got their lake and they can access the data that they need. It seems like a win-win. And in many respects, it is a win-win. You have sort of this partial application of schemas to that structured data. You're facilitating two different workflows from the same sort of central repository. But what it's not solving is that copying and moving piece. We still are having to copy and move our data, not only to the data lake, but then some of that, again, to the data warehouse that's within the data lake environment.
I think that, as you said, it's really pulling the elements of goodness from each of them, because again, each of these solutions is not that they're flawed, it's that they're solving a problem. But solving one problem doesn't solve all the other problems in the world. That's just how things work. But so the enablement of analytics through the warehouse and the recognition that establishing that central schema is hard and takes a long time, which the lakehouse allows the data to be kind of consumed out of the application such that it's stored, it's archived, you can come back and organize it later, as well as you can kind of enable data scientists to kind of have at it, understanding that it's unstructured, allows that data archive to be built up such that it creates a backlog that you can organize. So it really is pulling the best of both. And heck, you could even throw virtualization into the mix as well, right? Because building the virtual warehouse within your lakehouse on top of your lake without having to duplicate the data within the lakehouse. But again, everything is still centered in the analytical plane and isn't changing the application world of how apps work, how they interact, and all the things that we've talked about previously.
Yeah, absolutely. And I think that's a great point that you bring up, Dan, that, none of these are in and of themselves silver bullets. They're all designed to address a particular problem. And so, we frame this as a battle of modern data architectures, but there's not necessarily one winner, right? Each of these is addressing different problems that a given organization may or may not have. If I'm not doing a lot of data science, I'm not adopting a data lake. I don't need that. Data warehouse might work just fine for what I'm doing. And so what we've tried to do here is sort of talk about the strengths of each of them and what it is that each one of these brings to the table. So moving from the data lakehouse, we have probably the trendiest, I would say, of the modern data architectures in the last year or so. I feel like we've all heard a lot about data fabric in the last 18 months. There's a lot of disagreement over what data fabric is. I see that term used in a lot of ways. So we're going to talk about it in my understanding and present it this way. So a data fabric really tries to address some of the issues that we've been talking about all along, where you're not dealing with some of these fundamental issues of the data separation. So it's pulling in the data virtualization piece, where we have this sort of federated approach to querying the data, where our data is held in a network. And this is sort of the real key innovation of a data fabric. A lot of times you see this in sort of a knowledge graph context, where we've created some sort of graph or network of our data where we understand what our data is and where it is. And we have this shared semantic understanding of our data across all of these source systems. And we're accessing it where it lies. So there's this uniformity of centralized access over networked data. We're no longer moving it together or even pretending to move it together. Instead, we just know what it is and where it is. The other key piece here is we start to be able to deal with transactional data in a way that we haven't before, where because I'm not worried about trying to bring it all together, I can deal with high volume transactional data because I'm not moving it. I'm not trying to bring it into my data warehouse and getting overwhelmed by it. I don't need to aggregate it to deal with it. I can leave it in a transactional operational database where it is best handled. I can do the same thing with IoT data. Any of these sort of high volume use cases that tended to break older solutions that required it to bring things together, we're solving by leaving it where it is, but then having that semantic understanding of how to query it and its usefulness. Dan, I'll let you chime in here as well, because this is a big subject to tackle on this slide.
It is. And I like to think of the data fabric, and I also agree with what you said, is lots of confusion, lots of hype, lots of fake news. And these days it seems like every technology that deals with data is calling themselves a data fabric. But the way I think about it is it's the shift away from point to point to having a network-based approach. Like if I just think of even in my home here, I have lots of devices. I've got an Apple TV, I've got an iPhone, I've got a bunch of different things, but I don't run wires from every one of those devices to every other of the devices, yet anyone can interact with any other one. And how is that possible? Well, they're all connected via a network. So I to think of the fabric as really the data as a network approach brought together, whether you build your own or whether you buy, but that at a conceptual level is how I see it. But it itself is, in spite of the confusion in the market, which often happens when there's a hype cycle, isn't the panacea, because the idea of centralized governance is on one level sounds great, but at scale, it becomes very hard. Again, like who owns the model? Who's the designer? Who's the master gatekeeper of this semantic model? Good luck with that if your organization has more than 2 employees in terms of being able to maintain that. But regardless, I think what to me was the most exciting about this shift is this is really the first time where we're starting to zoom out of the analytical plane and looking at how apps work as well.
Yep, and I think that's key. So, that network data piece and starting to understand that applications are not some other world beyond the wall, but really part and parcel of the data that we're working with. Data doesn't know that there's a difference between analytical use cases and operational use cases. It just exists. And so starting to sort of architect around that is the big innovation here with data fabrics. And so I think part of the reason there's so much ambiguity here, so many different vendors are wading into the space, is because you can accomplish that in a lot of different ways, right? Like I can use different tools to do that. And so, I can federalize, I can use virtualization tools. So, you've got all these virtualization engines that are talking about being data fabrics, and because you could use a virtualization tool to create a data fabric, or you're looking at knowledge graph database vendor to say, oh, your enterprise knowledge graph, that's basically a data fabric. And again, it is to some extent, because it's this idea of let's impose a network, let's understand the semantics of our data and our data sources so that we can access that data across a network. But the key there is that networked approach.
Yeah.
The final thing we want to talk about, and I see there's some questions coming in, so we'll get to those in just a minute once we kind of get through this next slide. we want to talk a little bit about data mesh, mostly because it often gets tied together with data fabric. And it's something a lot of people have questions about right now. How does data mesh tie into these different architectures? Well, the starting point is data mesh is not in and of itself an architecture, at least in the sense of a technology, right? A data mesh is an approach to governance, is an approach to people and process that can be implemented using a number of different technologies. But the key sort of contribution of data mesh, for those of you who aren't familiar with it, is federated governance. So it's a move away from the idea, as Dan referenced earlier, of some sort of all-knowing committee that's somehow supposed to be able to understand data from every part of the business and impose some set of consistent rules across it, to the idea that different departments should really own their data as a product and then serve that to other pieces of the business. And so, there's been a lot of great stuff written on that, and I would encourage you to go look at it if that's a concept that's interesting to you, but we'll talk about it a little bit here. Again, this is the idea of federated governance joining whatever sort of environment you're already operating in.
Joe, that's particularly exciting because it unlocks scale. Because one of the reasons why all these others didn't ultimately, or very rarely do they deliver the ROI that was expected when there's a lot of hype around them when they're coming into an organization, is when you pair technology that brings things together, be it virtually or physically, with a central governance that ultimately limits the ability for it to support that consolidation, you have this kind of catch-22. You want to bring it together, but you can't really manage it in a together fashion. Whereas here you get interoperability without the need for that master modeler. So it allows whatever the technologies to be scaled, really, I think, for the first time.
Yeah, no, absolutely. I think it's an important framework as we start to grapple with, beyond the technological limitations of big data, sort of the human side of that, right? When we're dealing with big data, when we're dealing with lots of data, it's not just that our machines can't handle it, it's that we as organizations struggle to figure out how to handle it. And so the data mesh is a really concrete, almost architecture of process, more than sort of a technological innovation. All right, so we're going to summarize a little bit here, and I see we've got some questions, so we'll get to those in just a moment. To kind of wrap this together, we've talked about a lot of different architectures over the course of the last half hour. Sort of, we can divide them all into one camp, which is a traditional approach, versus Dataware, which we've referenced a couple of times, is sort of an emerging trend. They're starting to be Dataware platforms around an old idea, which is shifting our framework of what is relevant to data in terms of applications versus analytics. So in the traditional approach, basically everything we talked about today, you're bringing data together from a bunch of different application databases to one location where you can perform analytics on it. And what Dataware is saying is, okay, what if we didn't have to bring the data together? What if we didn't separate it to start with? What if we built our applications on top of a shared layer? Then that shared layer could be the data repository for analytics as well. But rather than trying to solve that analytics problem with an analytics hat on, the way sort of traditional architectures have done, it's taking a broader view in terms of how we develop applications and how we deal with data more broadly. Dan, I will let you chime in here with some final thoughts, and then we've got some good questions in the chat, so look forward to getting to those.
Yeah, no, I think you summed it up perfectly. The only thing that I would add to it is that this also opens up other opportunities beyond the combination of enabling federation and a network-based approach while eliminating and minimizing and reducing the integration complexity, is by having it accessible through a unified layer that is essentially a crowdsourced enterprise data model. Not only does it enable analytics to work and applications to work, but now you can embed intelligence inside of your applications, and you can embed operational capabilities inside of your analytics, because an insight that tells you something that you need to do and you can't act on it is useless. And so it starts to really blur the lines between, what is an analytical, isn't that just an application that is, has data as an input, produces an output, and that output triggers a business process. They're kind of all the same, actually, when you really think about it. But it also opens up the idea that people can interact with data more easily, right? So the enablement of direct access to data, because the data is accessible through the universal layer where the controls are not in the individual applications, they're at the data layer, is pretty exciting in terms of what that opens up in the future as well. So that idea of humanizing data is a big part.
Absolutely. Okay. We've got a bunch of questions, so we're going to get to as many of these as we can. So Victor asks, you still have a lot of applications like ERP and CRM and other legacy applications that still need a data extraction step in order to feed big data, data warehouses, or cloud storage, et cetera. How do you deal with those applications with Dataware or a data virtualization concept? Dan, I'll let you chime in since Cinchy, your company, actually builds a Dataware platform. How have you sort of solved that problem with those legacy applications?
Yeah, and I think maybe the short answer is it's not a silver bullet solution because you're not going to re-architect those systems. Even if you built them yourself, you're still not going to re-architect them. There's a lot of time and money that went into that, and they're very complex. So then the question becomes, okay, so if I can use these new concepts for new data, new applications, et cetera, is, well, how does the old legacy world interoperate? And maybe the simplest way to think of it is doing what I call a last copy integration. A different way of thinking about it is you're creating a digital twin of the data that exists in your ERP or in your CRM or whatnot, but putting that digital twin in the collaborative ecosystem such that digital twin no longer needs point-to-point integrations. So in the end, it is synchronizing a copy, synchronizing it in, synchronizing it out, but having that one copy is much better than the traditional approach of every time you're using it, you're copying it. Every time you need to use it, you're building integrations.
Yep. And I think that speaks to a question I had when I sort of first came across this concept of Dataware, which is, what do you do with legacy applications that aren't architected to use Dataware as a backend? And sort of one of the ways you described to me, Dan, that I found helpful was, Dataware in its present state dealing with legacy applications functions a little bit like a data fabric, right? But it has that added benefit of, as you develop or build new applications, you don't have to go back to that well of separating a database and applying that just to that one application and then having to integrate it. Start out with that data fabric, and then you can just build directly on it as you develop their in-house apps.
Yeah, and not even just building new applications, even if you're adding capabilities to existing applications. So you kind of think of it as you're basically doing model consolidation, normalization using a federated approach, but you can extend that model with new information because, hey, a new insight is new data. Someone is going to need to use it in some capacity. Have that data be managed independent of individual applications. That's the idea.
Absolutely. So Stefan asks, how would you differentiate Dataware from a good old DB2 database on a mainframe with many schemas? Or maybe it would be easier to differentiate with SAP HANA in memory or Oracle Exadata, where operational and analytics can coexist.
Yeah, so maybe the first part of that is, what's wrong with a central database with multiple schemas that, hey, you could even do cross-schema queries and whatnot. Well, maybe I'll ask maybe a counter question is, what's the difference between taking a file share and giving access to that or allowing everyone to have their own file share versus a document collaboration platform, right? What's the difference between Google Drive and me just sharing a network file store? And the answer is it's the capabilities that enable the collaboration. So it's not so much enabling the data to exist in isolation, yet be able to be connected. It's, collaboration is more than that. And the capabilities that are needed to facilitate incremental, gradual evolution of schema in a federated model is a whole suite of capabilities that just historically had not existed because, again, databases were not designed for that. It wasn't that they were flawed, it's just that's not what they were built to do. So in many ways, Dataware sits on top of that and adds those collaboration capabilities.
Yeah, I think that's a great way to put it, Dan. Andreas asked, how do you compare Dataware with the data catalog? And I'm happy to field this one. Data catalogs are another one of my areas of expertise. I've written a lot about that category. And Andreas, I can sort of see where you're coming from with this, right? This idea that we're sort of going to a holistic environment. We're trying to create some sort of shared semantic understanding of this. But ultimately, you got to think about a catalog as, just that. It's a catalog. It tells you where things are. Whereas with Dataware, it is what's housing the data, right? So with catalogs, we're starting to see some catalogs have an access capability where maybe you can write a query within the data catalog once you sort of identified the assets you want. But they're still not really a data repository in and of themselves. They describe metadata. That's basically what a data catalog is just a huge repository of metadata, data about your data. Now, Dataware also has metadata as a sort of key component of how it's constructed. And we'll, again, delve into this more next time as we kind of tease apart a Dataware platform and talk about what that looks like and the different components of it. But where there's that overlap is they're both managing metadata. But Dataware is also managing the data itself, and it's serving as a backend for applications. You can't write an application on top of a catalog. It's just not designed to do that. A catalog is designed for me to go, oh, I need data about X. Where do I find that? Dan, I don't know if you have any more to chime in on maybe the metadata approach of Dataware, but
yeah, well, we will get into that in the future, but it's maybe a little teaser. It's the idea of activating metadata and being able to put that metadata to work in some very creative use cases is one of the things that I say both data fabrics and Dataware, and to some extent data mesh, really take advantage of, which is almost going beyond kind of the idea of cataloging for the purposes of discovery to the point of having that catalog be driving decisions.
Yeah, absolutely. So questions keep coming in. They're really great. I hope we can get to all of them. But Bala asks, what do you think about the failures of data federation, data virtualization? Why? Do you see any future for it? Bala, I think we touched on that a little bit. It's not that data federation virtualization failed. It's actually sort of a key component of both the data fabric approach and the Dataware approach. It's just that it's not enough on its own, right? So we use it in the logical data warehouse context. The limitations from that were not the virtualization in and of itself. They were sort of the warehouse pieces. One of the things that's been really big for the data virtualization space is the advent of better, more efficient virtualization engines. That was a real issue early on. Virtualization, because of the federation, was just much slower. So when you're looking at sort of performance concerns, that started to be where you had sort of hesitations around the data virtualization approach. Great, I'm leaving the data where it is, but also it takes me a really long time to get there if I got to go through a bunch of federated queries. As that technology has developed, it's become much more efficient in that regard. I think the future of it is, what we've been talking about. It's that data fabric architecture. It's the Dataware approach. They use virtualization. So it's just embedded in these other architectures. Dan, I don't know if you have.
Yeah, and you're seeing this with vendors that used to talk about virtualization as the main keyword and reframing their offering. And it's not just simply a rebrand, it's adding in the additional capabilities that are required to turn that into a data fabric. So you're seeing that shift happening at an ever increasing pace.
Stephen asks, given that most of us are starting off with a traditional approach, how would you transition to a Dataware pattern? And I'm going to throw in, Tamina also asks, any readiness criteria you'd suggest for an organization to plan a move towards a Dataware architecture? So I think those we can answer them together. So how do we go from that traditional approach to a Dataware approach? What are the things that we need to think about as an organization to make that jump?
Yeah, I think the first thing is that you don't want to be thinking big bang implementation, but the first question to ask is the organization philosophically aligned with having data be the center in place of the applications being the center. It's kind of like a choice that you can now make. Before you couldn't make this choice because it didn't exist. But so it does have a major impact on an organization, which is why you need to throttle it, why you need to do it incrementally. You don't go and re-architect all of your existing systems. It's like one of the things that we see is the idea of applying it to your change projects as an accelerator such that you're easing your way into the transformation. So you're not going and rebuilding a whole bunch of things, nor are you carving out some multi-million-dollar Dataware project. It shouldn't be a project on its own. That's where you always get into trouble with ROI. But I think it's really just as simple as understanding it, finding out if the organization is philosophically aligned with that vision. And if so, the application of that is through the delivery of the projects that you were going to do anyway.
Yeah, I think that covers it pretty well. I mean, that main piece, I think, is true of almost any new technology, right? Start small, focus on, achievable wins. Don't think you're gonna, on your first move, change everything. That's just a recipe for disaster because that's not how people in organizations work. But I think that's one of the pieces when you talk about Dataware that lends itself to that incremental approach, right?
Yeah.
We start to pull in our resources one at a time. As we have new projects, we build them on Dataware instead of within other contexts. So we stop adding new data silos as we add applications. And we slowly bring on board all of our other pre-existing silos, right? We're not throwing out everything we've already got. We're just kind of bringing it together so we don't have to add anymore.
Yeah, the way I like to think of that is it's as if you're enabling projects to pay it forward. So if your first project requires you to hook in, like the earlier question around, big complex ERPs, if it needs to leverage some data from that, but it also needs to produce some new data, we'll have the new data be born inside of Dataware, meaning it's independent of the applications. Use that digital twin approach to pull in the data from your ERP such that you're solving that immediate project need, but the next project, if it needs that same data from the ERP, it no longer needs to do that. It's already there. It can be instantly accessed, as well as the new data can be instantly accessed through the universal layer. So every project is both unlocking existing data gradually, as well as changing new data such that you're not standing up new silos. So the net effect of that is, the more projects you deliver, the less integration you need to do.
And so I know we're just about at time here, so we're going to answer one more question because I think it's a valuable one that's going to be helpful for folks. Doug asks, are there particular technologies / vendors that underpin the shared data backend? Snowflake, SQL Server, Google Drive, etc. It's a good question, Doug. So when we're talking about Dataware as an architecture, it's one of those things you can build or buy. It's a pain to build, but it can be done. So Dan's company actually is one of those vendors in the Dataware space. Cinchy produces a Dataware platform, but Microsoft also has a Dataware offering, as does K2View. It's sort of a small space in terms of vendors right now, but sort of the key technologies are some of those we've been talking about, right? Like virtualization is a key piece of it. And we'll get into that more with our next webinar that looks at the features of a Dataware platform. That'll give us the opportunity to talk more about technologies. But Dan, I'll let you chime in there. Sort of what are those key technologies that you see as making up the Dataware platform?
Yeah, so it's interesting because in many ways, Dataware is just redrawing the boundaries between applications and data, right? So that they exist now on separate planes versus planes within these silos. So behind the Dataware unified layer is going to be, the technologies for persisting data, for storing data, for optimizing, for supporting transactions, for supporting, and that's where today, when you're thinking about this in terms of building persistence technology, you have to think of, well, are you looking at relational? Do you need asset? Do you need transactions? Do you need the schema flexibility of a document database? Do you need the inference capabilities of the graph database? Do you need, all these different complexities to solve all these different nuances? But by redrawing the boundaries, the applications no longer need to worry about that. They interface via the universal layer, which is Dataware, and Dataware itself on the implementation side abstracts that away. That being said, you have to somehow implement those interfaces and honor those contracts. And that's where you have to decide whether you're buying it or building it. But if you were to build it, then you would use a lot of these technologies behind the scenes. You would look at using existing persistence technologies. And perhaps depending on the usage pattern, you're using one versus the other. And when we were designing Cinchy, that's how we were thinking about it, which is how do you create that universal layer that supports transactional and operational workloads that I want referential integrity. I don't want schema rigidity. I want to enable plasticity. These are all the questions that you need to solve for in Dataware. And while they're hard questions, the impact of answering them is massive in terms of the simplification to the stack.
Absolutely. So I know we're over time. Thank you all for bearing with us a couple more moments to answer a few more questions. I think we had a really great conversation today. I appreciate all of your engagement. And I invite you all to come back for our next webinar, which is again going to focus more on Dataware, diving into the component pieces of it. We're going to have the opportunity to answer a lot more of those questions that we just kind of hit on a surface level today in terms of those fundamental technologies that make up a Dataware platform, fundamental capabilities. Really, how do we accomplish this shared data backend? Today, we talked about high level. How does this fit within that analytics architecture conversation? Next time, we'll talk about the technology itself and how it does what it does. In addition, you'll all sort of be receiving a link to a recording of this webinar, so you can go back and take a look at what we said anytime in the future, as well as a white paper that I finished writing recently, looking at Dataware. That'll be coming to you as well. Another resource to kind of dive into some of the things we maybe didn't get a chance to cover today. Thank you again for joining us, and I hope you have a lovely afternoon, morning, whatever it is, wherever you are. Take care.
Bye, everyone. Thank you.